Hi, everyone. Welcome to Beers with VCs, where we have casual conversations about the less talked about aspects of venture capital and startup building. We're your hosts, Sabrina Passman and Simon Lancaster. And today we are so excited to be joined by Chris Barton and Peter Atkin, who are the founders of Drafter. They are pioneering the transformation of engineering design and manufacturing. And we're so excited to dive into their vision today and get a sense of what the future holds. Chris and Peter, welcome. We're so excited to have you.
Thanks for having us.
Welcome, guys.
Woohoo. All right, around the room. What's everyone drinking today?
I'll go first. I have the best flavor, mango orange Spindrift.
Oh, nice. I've never had that one.
I've never seen that either. Wow.
That is a very unique flavor. There's so many flavors of Spindrift, like special edition flavor there. You got
Oh, wow.
Yeah, some limited edition. I have a Tonya, which is a beer from Nicaragua.
Whoa.
Yeah.
We've never had one of those on the podcast before. That's awesome.
I think
Yeah.
that's the furthest from home beer we've ever had. If we exclude Germany, of course. That's
Yeah, I mean, if you're going over to Europe,
Yeah.
well, you'll get further.
I've got a fancy tea today. It is pistachio tea, which I am very excited about. It's from this like very fancy loose leaf tea place. It's very cool.
Oh, wow.
It has a bunch of
Can you show
caffeine in
the
it
bag?
too. Yeah, definitely check it out. There's like a bunch of like really ridiculous tea options there, including like chocolate teas.
Lyra?
Yeah, tea Lyra, I think.
Okay. Tea Lyra.
Highly recommend.
Got it.
There's like
That's
thousands
awesome.
of teas on this website. It's wild.
Wow, we got to get a sponsorship from them after that.
I know. brand sponsorships. We're on it. How about you, Simon?
Okay, I've got some good old Corona knockoff Pub Cerveza, cheap fun. My favorite slogan of the year. Yeah.
Woohoo!
Yeah.
All right, cheers, guys.
Cheers, guys.
Excited to get into it.
Cheers.
Cheers.
Awesome. Well, firstly, congratulations, you guys, on coming out of stealth. We're so pumped. I have to say that supporting Drafter is one of the fastest checks that we've ever written because the vision really resonated with me in my previous experience working as a product designer at Apple. I would love for you guys to kind of paint the picture of what you're building. Peter, can you give us like the 2-minute elevator pitch?
For sure. Yeah. And I'll just start by saying it's awesome working with you guys because you are users, right? Or like ex-users of this product. And so it's been awesome to build with you folks. Yeah. So elevator pitch. We are building and bridging the gap between the hardware engineering world and manufacturing, right? And we are starting very intentionally at the intersection of those two ecosystems. So we are very focused on the 2D technical drawing, which is what connects those two worlds, right? And it takes the 3D models from the design engineering world and it gives them the manufacturing specifications that are required to go actually fabricate those things. We can go into why we're solving a problem there, right? We'll kind of go into that, but we're really starting there because that's where design intent lives today. That spans both engineering and manufacturing. And our goal is, as Drafter, to be the design intent company and kind of fundamentally change how people are designing things for the manufacturing world, right? And bringing those two things together. So that's Drafter in a nutshell.
Yeah.
Awesome.
There's so much to dive into there. I want to also highlight that both of you have quite different backgrounds. Chris, you bring the product and business scaling knowledge. Chris, you bring the technical knowledge. I really want to double click into both perspectives today and like how you guys converged on this vision. But maybe Chris, can you start by describing why you're so passionate about this space and like given your previous work experiences in your career?
Yeah, definitely. So Peter and I kind of have the yin and the yang. I come from an entire career of being a mechanical design engineer. I've spent the last decade building low volume, large scale things in high criticality spaces. And so I have, built some amazingly high technicality things. And I've also broken a lot of parts. And the entire time that I have done that, I've been frustrated and infuriated by the tools that have been at the disposal of mechanical engineers. And, interestingly, I've always been a process person. I've always been fascinated by how we can do things that we as a team are doing better and faster. And Drafter is really the result of 10 years of pain, of hating doing drawings, of hating having, the small mundane things that happen at the end of the design process. You've made this amazing thing, you go and order it and you miss one thread call out. And guess what? that part is shit. You have to go back and order it again. You have to tap the threads yourself, right? And this is the reality that every mechanical engineer understands. So, over my years building antennas for satellites, building parts of the Dream Chaser spacecraft, working on modular houses, building robots that were printing houses, every single one of these different applications has the same pain points. And this is why Drafter's here. We're going to solve this problem for every engineer, regardless of what they're working on, so that innovation can happen faster and people can move quicker through that entire process with less overhead, less energy, and overall more innovation.
Yeah. And for those that aren't familiar with like the manufacturing design space as much, can you describe like this is such a pain point of my previous experiences as well. I will spend like managing like hundreds of drawings per assembly, and we'll have, so much to just generate. And there are some drawings that are extremely complex and take, like 90% of the time. And there are a bunch that are just super throwaway drawings. Like you got to make them, but if you make a mistake on one of those, it can totally trash your whole project. Can you explain to me like why the drawing itself is like the nucleus for this relationship between both parties?
Definitely. Yeah. I mean, so the way that things get built in the modern day, right? Everything gets designed in a CAD ecosystem. And what that means is you now have this 3D model that represents all of your components that are going to come together. And the thing that's interesting about that is in that 3D model, it is perfect. There are objects that have exact values, but the real world isn't perfect, right? You take this beautiful mango orange spindrift, the diameter has an exact value in the CAD model, but in reality, depending on the temperature or time of day that was rolled, right, that will vary based off of the manufacturing processes, the raw material that went into it. And so communicating from a mechanical engineer, the ranges of acceptability are what we call tolerances. And the drawing is the vessel through which tolerances are communicated to somebody. And so a mechanical engineer's job does not end when they have a perfect CAD model. It ends when they receive something back that is manufactured within the ranges of acceptability for their design intent or for their purpose. And so really we're building the perfect tool to communicate all of those effectively. And right now that process is super arduous, right? You spend all this time designing, you spend all this time testing, and you get to the point where you then have to recreate this asset that has these ranges of acceptability. And so Drafter, automates all of the mundane process there. So engineers can purely just think about what is important to them, what the ranges of acceptability are, and communicate just that, right? We are reducing all of the other time that happens so that they can communicate what's important to them in a small amount of time.
Yeah, the tolerancing is such a pain in the butt, honestly, from getting everything to get together. Yeah, go ahead, Simon.
It sounds like a very, listening to you describe it, Chris, it sounds like a very critical and exciting part of the job, right? But it really becomes very mundane and tedious, right? After doing all the design work, especially given that you need to really have so much attention to detail on a lot of areas.
Mm-hmm.
Yeah. And just to give you guys some, for people that don't know kind of the context of the amount of time we're talking about, like we commonly see companies and a lot of our kind of early design partners, their engineers spend over 20% of their time on drawings, right? That's creating them, that's going back and forth with people that are checking them, reviewing them, talking about the different symbols they're using and if that's the correct one and if that range of acceptability is okay, going back and forth with manufacturers on them, right? And so this is a significant amount of time that we want to give engineers back to go and actually do impactful design, testing, iteration work that moves the needle for their business. So that's the goal.
I think that's the key to why, that's the crux to why it's so tedious, is because it's just kind of the software to make drawings has been stuck in like the early 90s, really. It's like basically still like AutoCAD, right? From 30 years ago.
And the thing that's crazy about this, right, is these hardware organizations, it's all about reducing risk, because if you mess one part up and it breaks, right, that thing either fails and it puts someone at danger, or it comes together and you can't assemble it, right? And so you then have to go order those parts again. And so these companies, in an effort to reduce risk, have hired specific people who check all of these drawings. Some companies, Drafter's name is very aptly on the nose, hire drafters who just create these drawings, right? And you now have someone very expensive, very tenured, who is spending all this time just doing mundane work because they have a high association, high ability to focus on those details. And so what we're really excited about is empowering every mechanical engineer to be a full stack mechanical engineer, which means that they can own that part, own their responsible engineer, right? Every part that they own from end to end. That means through manufacturing into truly like having it performance function in its specific place.
I love the idea of digitizing that knowledge base because it really does feel like there are very relatively specific formulas for every type of part, for every type of material that you manufacture. One additional layer of complexity of this, though, is that also manufacturing method can play a really big part. And as an engineering designer, you're not only thinking of like what you want your perfect model to look like in an ideal CAD system, you're also thinking about what are the ways to actually manufacture this part and enable your manufacturing engineers to be able to pick a manufacturing method that actually is feasible in the real world. Is that part of your guys' vision of integrating the manufacturing method recommendations later down the line and rules associated? Like, can you walk us through what that could look like?
Yeah, that's spot on, right? I think we've been really focused today on what we're talking about, which is automating these drawings, getting rid of this massive pain point that exists, making it much more efficient to get to high quality specs. But that's not why Chris and I started Drafter, right? That's a very small component of the vision. What we want to do is actually bring that understanding of manufacturing and the real world implications of how things get made further upstream into the design process so that folks can design in ways that they cannot today, right? With an understanding of, hey, how is this CNC machine actually going to approach fabricating this part, right? Or help me choose the fabrication method for this part, right? And that all comes from this design intent, which we're focused on with the 2D drawing, right? Merging that geometric understanding with the actual manufacturing specification understanding and building systems, right? That can understand how to help designs get manufactured in the best way. And so by digitizing this information, we can obviously start to train systems on that information, right? And it's really cool that we're building at a time where, data is so valuable with these deep learning models that can exist and learn in ways that humans cannot. And so that's what gets us really excited, is building towards that vision where you have a generative design tool that can actually build things that could be manufactured versus today. I think we've all seen the really cool NASA structures, right? That have been generally designed and they're super biological looking. They are amazing in so many ways, right? Like they are totally optimized for the requirements from a design side, right? For materiality, for strength to weight ratios. What they are not optimized for is getting manufactured at a cost-effective rate, right? So that's what we want to do. We want to kind of democratize the access to these generative design tools, right? By saying, hey, go use this. It'll design something that actually works for your business use case because it can get manufactured tomorrow by someone, right, in the United States, by someone who has a CNC machine versus some crazy advanced additive manufacturing process.
I want to pause and underscore the importance of this vision. So as VCs, we've seen such a ridiculous wave of Gen AI led technologies that, because you can make cool looking stuff with DALL-E and you can make interestingly shaped things in 3D space conceptually, those companies have been getting a lot of funding. And we've had such a hard time getting on board with those types of companies because it doesn't actually translate to reality. Can you guys describe why you didn't have a beachhead of Gen AI to start and are instead starting with this more fundamental piece?
Totally. So context, right? Context is everything. We are the design intent company. And that means that we can't just take a part in isolation and understand the context for which it was designed, right? A part is a piece of material that contains features. Those features all connect to other things or serve a function within a larger assembly or within the world that it is used. And so by taking this beachhead, we now have a moment where we understand the context and we understand the implications. And so we're bringing the tribal knowledge that exists in the downstream manufacturing worlds, in the materiality worlds, and making that widely available to mechanical engineers so that they can then go and move their process downstream And our data set that we're going to aggregate at this moment will have all of the design intent, all of the context through which we can now go truly train something that understands the implications on why it was designed this way versus pulling apart off the internet. And who knows what was around that, what the intentionality of that designer was in the moment that they created it, right? And so we are being very strategic with why we are adding value to mechanical engineering ecosystems today. And in doing so, starting at the right point where we can aggregate the correct information.
Yeah, and I think crucial to that is this data does not exist today, right? What we are doing is we're collecting a first of its kind data set that actually takes those geometric properties and matches them with the manufacturing requirements and outputs, right? All of those today are on static PDFs that live, hopefully on files on people's computer instead of piles of paper on their desk, but it's a mix of those two. We're going to collect that data, right? And that's really the valuable asset here, right? The models are really great when they have a bunch of data. So starting with the application is not going to work in this space right now. That's our belief, right? You need to start by building a data set that you can use to train those models to then actually have impacts on the folks that are using them.
I'm so excited about the way you guys are building this. I think it is so critical, especially for these technical industries, to start from a basis of like data first. You can't start from like concept and like vision first in these ideas, because really like you're dealing with like physical parts that need to actually be measured to specific and designed and tested to specific specifications. And so training off specific data sets is like chef's kiss, beautiful. I'm really excited about the way you guys are building it. And I am curious. So you had your launch this week, which is a couple of weeks back, which is very exciting. And we're really pumped to have users like figure out how to find the platform and use it. What does the experience look like? How has your building experience so far gone? Can you walk us through like the life of the early stage founder?
Yeah, absolutely. So, the response has been amazing. People are so excited about what we are building, and, kind of to that earlier point, they are coming from all walks of life, right? These are people designing things from medical devices to automotive to aerospace to robotics. The outpouring has been awesome, and engaging with them has been really fun to see that we are hitting on a pain point that exists regardless of the team size, regardless of the ecosystem. And so, a day in the life, we are trying to meet the demand that people are bringing to us right now, getting this platform into as many hands as we possibly can and listening to them, right? Making sure that all of the conversations that we've had leading up to this continue to ring true, and working with them to make sure that every ecosystem is being sufficiently met with our first product, right? And part of this is like, it continues to get bigger from here. We're really excited, to be able to continue to serve more and more of this early pipeline by bringing in entire assemblies, doing tolerance stack-up analysis for them, right? Like continuing to improve the product so that we're not just solving this singular pain point. It is the entirety of the pain that exists around the mundane work between design and manufacturing.
This is
I have to say something.
I wanted. Yeah, go for it.
Yeah. I'm going to say something along those lines.
Yep.
It's like, it's been a year since we made the investment. Time has flown by, like meeting with you guys regularly and helping with the go-to-market and the product has been incredible. But this is probably the most like exciting yet frustrating one I've been involved with, because there's been so much anticipation, and I knew people would be really excited to see the product. I've been wanting to like make more introductions and stuff. And now finally you're out of stealth after a year, and it's really cool. Like, I think even earlier this week, Peter was asking me for some introductions, which you guys are always really, really good about, very selective and targeted, which is always helpful. And I was like, I'm not sure if this guy's gonna respond. He hasn't, some engineering director at a massive, extremely well-funded company, late stage startup, and like he immediately responded. After I haven't heard from him in like years. He immediately responded and was like, "Man, if this works, like I definitely want it.
Yeah. It's so cool to see those moments, right? I mean, we've been doing hundreds and hundreds of calls over the past year. And to see people's eyes light up, right, when they're confronted with a fundamentally different way of getting through something that has been a toil on their whole work life. It gets people excited, which is so fun for us to see, right? And yeah, I think on reach outs with people, right, if we just share a little bit of information, we're seeing a lot of positive response back, I think, hinting at the demand and the pain that's being felt on the other side.
Yeah. Pain. Okay, last comment, then Sabrina, I'll let you get back to the great questions. We've always, I'm not sure if we've mentioned this on the podcast before, maybe we have, but we've always believed in founders that leave their day job to solve the biggest pain point of their career. And in this space, like, you really have to have lived through industry for at least a few years, like you have, Chris, to like really fundamentally get that and decide to make that decision and be smart about that decision, right? Like, this isn't an industry where you graduate mechanical engineering or industrial engineering or something like that, and you're like, okay, this is a problem that exists. Like, this is something that you wouldn't really even know about necessarily until you've lived and breathed it. Yeah.
This is a really interesting thing about what we're working on. So one thing that's novel and unique about our product is that we produce drawings that contain GD&T, which stands for geometric dimensioning and tolerancing. And this is essentially the language of numbers, letters, and symbols that is used to communicate perfect manufacturing instructions in a way that manufacturers can receive it and it can be measured accurately. GD&T is not taught anywhere formally, right? In CAD classes, I was talking to some SAE students the other day. They take a quarter-long class on CAD where 1 week of it is based on drawings. And there is a mention on 1 day of GD&T, which means that onus of teaching that falls onto whoever hires them directly out of college. And guess what?
Yeah.
That doesn't happen, or it doesn't happen effectively. And that education comes from working within the industry and messing things up and learning from the people who are your advisors and mentors, right? And, for a lot of people, we've interviewed hundreds of engineers, and you would be astounded by how many of them have admitted that they don't fully understand GD&T and they use it almost every day. And that's crazy, right? Like, that's where this platform of giving you something that has perfect language on it is going to be incredibly valuable, whether that's to the greenest engineer or the most senior person who wants to save time.
I can absolutely vouch for what you just mentioned. Even within my previous job experiences, there would be like a 1 to 2 day training in which you'd say to totally green engineers, like, this is GD&T, like, here's 3 examples, learn them immediately and go apply them. And it's like, I still have no idea what the heck I'm doing. It took like years of like making bad drawings, getting them reviewed and basically torn apart by the people with like 5-6 years of experience plus, to say, okay, you need to totally redo your datum structure, for example. Like, you need to totally redo XYZ. And that really does, if there were a teaching tool to help with that, which is also like that's not nearly the focus of Drafter, but it's absolutely a benefit. Like, you're going to be able to understand like what the best method for creating any product can be. That's going to be hugely transformative for the efficiency of like actually getting drawings out there, which I'm very excited about.
So we've heard this from hundreds of engineers, and we've actually decided that we need to, both in creating a standard of how drawings come out and look at the end, we also need to educate the people who are using our platform. And so we have tools built in where we're providing education on how you should think about tolerance zones and how you should think about datums. And we're every week continuing to post content on how people should understand this so that we can educate, right? We want to do the work for you, but you need to understand what you are producing. And so we're building education into this tool because it's a great platform to do it. And we believe that it's going to really lift the entire industry up by having engineers understand what they're working
with.
Yeah. And I just want to highlight, Sabrina, one thing that we've heard from folks, right, is like the only way to learn this today you have your GD&T class where you're on your phone half the time and you don't really learn anything, right? The only way to learn is by doing and by messing up, right? And by getting a manufacturer to say, hey, you can't do it this way, right? And so each individual engineer over the course of a career becomes good at GD&T when they're using it all the time, right? But, you know, that isn't good enough, right? It's not okay to just have people building tribal knowledge that you can't really transfer around. And so what we want to do with Drafter, what we're doing with Drafter, is building a tool that gives you that feedback and gives you that education on a much faster cycle, right? And so now we're not only producing drawings, as Chris was saying, but we're helping you understand GD&T, why these drawings are good, and you become an expert without having to go through years and years of pain and feedback and failing to get there.
And we can do that with not just GD&T, right? We can do that with how you call out fasteners, how you think about materiality selection. This is where the different types of tribal knowledge that we want to build into this large tool, right? This is the vision that we're working towards, is you have that professional manufacturing engineer sitting on one shoulder and your GD&T expert on the other. And you now do an amazing job on the first time you take a pass at that drawing.
I'm like literally getting tingles. It's like exactly what I wish I would have had at my old job. Like that, what would have been hugely transformative for any given team. And like the way you guys are building this is so thoughtful. I love the nucleus that you've started. And I think this is a huge testament, Peter, to like your product background and like the way that you came from not just not mechanical engineering, but maybe you can walk us through like how your previous experiences have helped you like develop the way that you guys are building this company together.
Yeah, for sure. So, you know, I come from the software world. I studied cognitive science and computer science and then was a consultant at Apple for a couple years, working on some software products there. And then I went over to Eclipse Ventures and was helping build out their venture studio branch of the firm, right? And so working with founders over the course of a few months to launch new companies. And, you know, Eclipse is an industrial focused VC. And so there were a lot of hardware companies, right? We were working with robotics companies, manufacturing companies, aerospace companies. And so I became exposed to the world of hardware development in a way that I had never seen it before. And I became completely fascinated with the tools and the processes that I was seeing, and really how different they were from my software world and the tools and that we had to build products there, right? And by no means a novel insight, right? But one that just became so evident to me when trying to work with folks who were mechanical engineers building robots and being like, this does not feel like it's the year 2023, right? At that time when I was working with them, like this feels like it's the 80s or something. And so that's when I became, you know, fascinated with all of the problems that existed and what seemed to be like very juicy opportunities to go solve some problems. And so I started talking to a bunch of mechanical engineers. Chris and I met in those conversations and just hit it off, right? We both aligned on kind of the pain that Chris had experienced, what I had seen. We both aligned on kind of a vision of what it looked like to go solve this. And then, you know, took a lot of what I had been doing at Eclipse in terms of company incubation and used that in our process. So, right, on our first call, actually, Chris killed one of the ideas I was working on, which is awesome, right? That's what you're always looking for when you're trying to start a company or a product, is like reasons why you shouldn't do it, because those are a very, very efficient way of going about figuring out what you want to do, right? So finding those really quickly, killing bad ideas. Chris and I started roaming around together, talking to a bunch of mechanical engineers, testing out different ideas, and we landed on this one that we couldn't kill, right? And so, you know, there's 100 reasons why any product's not going to work or why any company's not going to work. And so you got to gather all of those. But we were looking at them and we were like, we just can't kill this one, right? Like there's a chance that we can really go and build something here that is transformational, right? And kind of this vision that we've been putting forward. And, you know, I think you get to the point where you're like, hey, there's a chance that this could work. And that's the point where we decided to commit to this, right? It's too exciting. It's too important. We believe that we can go and really do this. And so that was my process to get here. Obviously different than Chris's lived experience, but I think that's how we complement each other pretty well.
Absolutely. It's like something we noticed right off the bat when chatting with you guys.
Sweet.
And
how much of it was from talking to users that early?
Oh man, I'd say like it's 95% talking to users, right?
And then being just like, this is the bane of my existence.
Yeah, right. You're
Just
looking
like-
for
Yeah.
and yeah. Go for it.
I was just going to say, like, when looking at this company and product from the very beginning, there was like a balance of like, okay, go to market, huge pain point, TAM, still large, like for us, for an early stage firm, large. But I think like the balance of like the big picture vision, which you talked a little bit about later, and yeah, would love to hear a little bit about your journey through that.
Yeah, I think it's a constant process of zooming in and zooming out, right? So zooming in is, hey, do we have what it takes to solve a very acute and immediate pain today, to go to market in a way where we can start to build enough traction, right, in the right way? And that's obviously going to start pretty small in the grand scheme of things, right? Like automating 2D drawings, super important. It's going to solve a lot of pain. It is not going to transform the hardware development process as we know it. So the question you have to ask yourself from there is, okay, zooming out, like what can that enable us to go do, right? And Chris and I have an immense belief that we just talked about in terms of the data aggregation and being right in between these two ecosystems, that by starting here, we can go and really fundamentally solve some much greater problems in how things are designed for manufacturing. And so then the TAM for that explodes, right? Then the problem that you're solving explodes. Then the way that you are actually changing the industry totally explodes. And so, you need both. I think, Sabrina, to your point, right? Some people try to start with the big vision, and I think that can work in a lot of cases. We believe that to solve problems in this space specifically, you need to start with that kind of wedge beachhead, right? And it needs to be a very intentional and specific beachhead that you're starting with. And so all of those pieces need to come together, and right, that's what we believe is happening.
That's really, really helpful advice, I think, for a lot of our audience. We have so many either engineers that are at their day jobs today and thinking of like, what business can I start? Or, maybe they have a nucleus of an idea, but they want to figure out how to like prove traction. Like, can you guys give advice for those folks of, firstly, like how to identify the right idea? And then secondly, like how to really vet that before you start, raising funds for a pre-seed?
Yeah. I mean, determination and malleability. Like the idea that we started with in June of 2023 is very different, but similar to where we are today. And if you have an idea and you stick to it, you are probably wrong. But if you take an idea and you talk to people and you kind of manipulate that idea and you talk to more people and you end up coming out with, right, like you polish coal enough, you'll get to a diamond. And you have to be able to continue to do that. And so finding a place where you know that there is pain. Everyone always says, it's easier to build in something that you've done for years. I hated doing drawings. I hope that we solve drawing pains for everyone. But if we only solve drawings, that's not big enough, right? Like we need to drastically change the way that things get manufactured in the world today. And to do that, right, this is the small part where we're going to solve pain. It's going to allow us to increment until you get to the point where we've drastically changed the way that people use tools, right? If you create something in CAD and you send it into Drafter and out the other side, you get this thing that is both manufacturable, that has lead time, it has materiality, that it's going to be consistent with your use case, and you can immediately send that to a manufacturer digitally. We've now drastically changed my entire experience as a mechanical engineer. And that's the world that I want to live in, right? That's just the tip of the world that I want to live in, because people are going to use this to do amazing things. We want to empower them.
That is such a beautiful vision of the future. I can't underscore this enough. I think like for those who haven't survived through any product design or manufacturing previously, it won't feel as amazing. But if you have any experience, like how transformational that's going to be. And it genuinely, I really resonate, Peter, with what you were saying of the software advancements that you've just come to be comfortable with in every other aspect of your life. It just has not been applied yet to the manufacturing and engineering industry yet.
Yeah.
And it's so silly to realize that most people are living on even paper, Excel, like these really outdated tools that only get you like 30% of the way there. And there's so much additional work that has to be done. when in every other aspect of your life, you can like, pull up ChatGPT and like get answers to like a million different things in like the click of a button.
Yeah.
It's a wild difference between.
Yeah. I mean, the first time I watched someone do a tolerance stack up analysis, my jaw almost hit the floor, right? It's like, I cannot believe this is how we are building things that are going to space, right? Like, this is the process. And it just, right, when you see problems that do that, it's like, we were, there's a really interesting, we were listening to another podcast, highly recommend Manufacturing Spaces by two friends of ours, Pete and Em. They were interviewing Carl Bass, and Carl Bass, godfather of CAD. And he was talking about drawings. And I was so interested to hear like what this guy who had spent so much time in CAD, and he invented Fusion 360 pretty much, right? Like, what was his take on drawings? There must be a reason why they exist, right? And he was like, I cannot believe that, like, in 5 years, I better not see a drawing, right? But like, and just when everyone agrees on something like that, right? You have to think, okay, why hasn't something changed? And there's plenty of good reasons why things have not changed, but it's only a matter of time, right? It's inevitable. We're going to get away from drawings, and we think Drafter is the company to go do it.
Mm-hmm. I can't agree more. really pumped. Mm-hmm. I want to also underscore for the founders and like nascent founders in the audience, like your guys' backgrounds are like perfectly suited for building this type of company. I think you guys have a really good understanding of the technical depth that's required and are very adept at tackling that. But also, given your guys' different backgrounds, you really complement each other in a really powerful way. I'd love, just candidly, if you guys have any advice for like finding the right co-founder. And I guess early in your process, like, Peter, did you like talk to many Chris's before, and then you like realized Chris was like the one, or like how did that early stage process really work for you guys?
Yeah, I don't have like a like playbook here for going to do it. I think you just have to like kind of do what Chris was saying before, where you focus in on a problem and you start talking to people, and you kind of find folks along the way that are believing enough in what you're doing, believing enough in the problem, and you kind of go from there, right? I think there's many paths. You can find friends that are interested in it, old coworkers that are interested in it. You can find people along the way when you're interviewing them about an idea, right? There's like no silver bullet. And then it just takes, a process of getting to know each other, right? Chris and I spent 7-8 months working together before committing to the idea. Of course, a lot of that was refinement of the idea for the company. But obviously a good amount of it too was Chris and I getting to know each other, getting to know each other's working styles, what on paper looked like a good co-founder complementation. Did that exist in real life, right? And coming to really positive answers to all those questions. And so, there's no silver bullet. I think just start looking at problems that you think are interesting, start trying to solve them, find smart people to think through them with you, and things will happen from there.
I love it. And Chris, do you have any like feedback on like how when Peter approached you originally, like how that dynamic was on your side?
Yeah, I mean, I had done a lot more reaching out to people. I had probably taken 75 calls of people who were trying to build things, interested in building things, and just figuring out like what people were working on in the world. And I think, my advice to anyone trying to do it is, 1, do it. It's the best decision I've ever made. And 2, be yourself. Like, I tried to put myself into different boxes, and I'm really glad that I had that experience of realizing what wasn't going to work. But also, in the partnership, like, you can't not be yourself and find a co-founder, and you'll end up harpooning your company, because from day one, Peter and I have been incredibly honest, communicative, and straightforward with one another. And like, finding that dynamic is incredibly important. We talk almost all day, every day. And if you can't be direct and straightforward in the way that you're trying to communicate, there are many ways for a company to die. And, having a great co-founder relationship is one of the things that I'm positive we have and really excited about. And, it takes hard work. Like any relationship, it takes hard work. And having a co-founder, is a lot of time that you're spending with someone.
Yeah, there's a lot of analogies to dating, and those analogies are not wrong, for sure. It is an intense, all the time relationship.
Slightly awkward.
Yeah.
Sabrina and I go through this sometimes, although we are independently married to our own partners.
Yeah.
Everyone's clarification. We often joke
It's
there's
so
like
funny.
implied nuances around this.
But it totally is like the relation. Like I talk probably, Simon, to you more than like anyone else in my life, and it is so important to find someone that you have complete trust with, because if you don't have that trust layer, you're never going to be able to like navigate hard business decisions. And as a startup, you have to do that daily, you know, and it's something that it never really gets easier. You need to find someone that you're willing to like, you know, hunker down in the trenches with and like have complete trust. They have your back. You're both walking towards the same vision and goal. And yeah, I'm hugely impressed by the dynamic that you guys have been curating and like your thoughtfulness. Even in one of our first conversations, I think you were already defining like the core values that you guys wanted to share. And that was incredible from just like a maturity standpoint, showing that you guys not only like incredible product, incredible vision, but also completely balanced in terms of how you're thinking of approaching this from a very long-term standpoint. You want to make sure that your team and, you know, the nucleus of that being your guys' relationship is strong so that you guys can move forward with that. So wanted to shout that out too, that it was hugely impressive that you guys were prioritizing that even from the jump. So
yeah,
kudos there.
And although I completely agree, co-founder relationship and partnership and trust, super, super important. You guys are awesome. For all those other founders out there, co-founder therapy is a thing. Like there's professionals that focus on this. And just like a marriage, like you don't need to wait for a crisis to like go to couples counseling or like building trust and building relationship. But yeah, I think it's very important having super high level of trust, because when times are good, you know, things are easy, but you never know when things might turn more difficult. And that's when you need the high level of trust, right?
Yeah.
Totally.
Yeah.
And I mean, another thought on this is like find someone who is different from yourself, because the way that we complement each other and challenge each other on our approach is part of our success, right? If we had two mechanical engineers, Drafter might not exist.
That's right.
It is the pressure of doing those things together and making sure that the outcome is positive that works.
Yeah, and it's interesting that you mentioned challenge. You mentioned challenging. I think that's so important. It's like learning to challenge each other in a high trust environment where you don't get offended, you don't get defensive, but you like just legitimately listen, absorb, counter, and you can both do this in a like that. That's so important, and not to feel insecure or defensive. Yeah. It's really like the sweet spot, I think. Okay, cool.
Yeah, super excited about what you guys are building, the way that you're building it, the way that you've built not just the product side, but like ground up company relationship and everything. I feel like we could gush about you guys for longer, but in the interest of everyone's, I guess, ear power, I'd love to ask our final question on our podcast today. And that question for each of you is, who has the most impactful person been in your career and why?
It's a good one.
Awesome.
I'll go first. I don't have a single person, but I have learned from so many people that I've worked with. I had internships where I was the dumbest person in every room that I worked in. And that was awesome, right? Like gleaning knowledge and learning how to learn has been the single best thing that I think came from my engineering degree, that came from a number of my experiences. And just like watching the way that people effectively do their job. I've had some incredible managers who are just the most tenacious, hardworking people I've ever witnessed. And like learning 5 small things from those humans has made me who I am today. And so it's hard to point to a single person, but like every single person I've worked with, and I've had the fortune of working in incredibly high velocity places, has really galvanized me into, you know, the person I am today. So I know it's a little bit of a cop out by not having a single person, but
No, it's incredible.
It's been in the presence of, you know, incredibly hardworking others.
Cheers to them, for sure.
Thank you.
Cool. I'm going to go with a bit of a blast from my past. I don't know if you guys know who Dan Ariely is. He's a famous behavioral economist. He has written a bunch of books. The one that really hit home with me is a book called Predictably Irrational. And it's about human behavior and how we make decisions that are completely irrational, but how you can predict that we are going to do those irrational things. I reached out to him after reading that book and was able to intern at his, called it the Center for Advanced Hindsight when he was at Duke. And completely, like, it was the first time where I became absolutely like ensconced and interested and couldn't get enough of something that was like academic and not like, you know, sports or, you know, whatever it was growing up. And so really like lit my intellectual and academic fire, and led me to then kind of map that onto technology, which he started to do as well. And is the reason why I studied cognitive science and computer science and sent me on that path. And so, you know, all the branching trees of life, that is the one that kind of, you know, was the trunk of sorts of putting me on this path. So really appreciative of him and kind of just that curiosity that it sparked in me.
That's amazing. Cheers to him. That's so incredible.
Cheers.
Woohoo. Guys, thank you so much for your time and sharing your grand
thanks,
vision for like how you're transforming the manufacturing design industry. We're so excited for this future that you guys are building. And yeah, thanks for sharing all your insights.
Thanks for having us.
Yep.
This was really fun chatting.
Yeah, it's awesome. And we also, with you guys coming out of Stealth, we recently published Why We Invested in Drafter, which I've been waiting to publish for a year. Really excited. Take a look at it for anyone out there. We'll also post it in the comments. Yeah, it was great finally chatting with you guys publicly. And I'll sign us off. This has been Beers with VCs with Chris Barton and Peter Atkins from Drafter. Have a great weekend. Cheers.
Cheers, everyone.
Thank you guys.
Cheers, folks. Thanks, Omni.
Bye.